Well, I can tell you I'm looking forward to this. Brody Kostecki in the Camaro, the Gen3 Camaro, Cam Waters in the Mustang, going to fang him around this Adelaide street circuit. But you know, for all the things that are similar, there's a lot different on these cars. They're still going to be able to be tuned with suspension, spring, shocks, geometry, there's strategy, there's tyre pressure, and of course there's the drivers. But what's critically important as we go forward with this new program is that the engine horsepower is the same because they are different engines and they are completely different body shapes, and they have to make exactly the same aerodynamic performance. That is critical. So I went off and did a couple of stories. We'll put together a couple over the course of the weekend. Here's one just to give you an insight about just what's been involved in getting these paratised in terms of aerodynamics. As part of the much anticipated introduction of the Gen3 Mustang and Camaro at round 1 Newcastle next year, I've found myself here at Wellcamp Airport at Toowoomba on a beautiful November day. So I'm here on the back of what's been an 18-month journey for the Supercars Motorsport operations team, their technical partners, including Ford and General Motors. It's been a gargantuan task of bodywork and aerodynamic design that's now culminating in a final week of detailed aero testing at this aerodrome just to get the little 1%ers right. But for now, I just want to pay credit to this process and give you an insight, some detail into the energy, the work and the resource that's being used to achieve some very specific outcomes. What are they? 1, aerodynamic parity, the exact same downforce and drag across a wide range of dynamic parameters. Number 2, an overall reduction in downforce from where we are now to improve the quality of the racing. Number 3, make drivers work harder and cars closer together. And amongst all that, pacifying the requirements of our manufacturers to make sure these race cars remain true to the body shapes of the road cars they represent. Now, our current cars make bucket loads of downforce. In fact, when we're going through the chase at Bathurst, 300 k's an hour, I'm going to estimate about 800 kilos of downforce. And with these new Gen 3 cars, we want to get something like 60% of that downforce off. And we want to do that across a wide range of speeds, from slow to fast, matching the downforce and the drag. And that's why we're doing it here in a controlled environment that is an aerodrome. Now, drag, like a parachute, is less of an issue for our cars because of the powerful V8 engine. But needless to say, it's got to be exactly the same across both cars because it impacts straight line speed and, most importantly, fuel usage, a big part of our game. So from where we've been for many years, things like wing profiles need to be smaller, less aggressive, more efficient, and that includes the wing end plates. And up the front of the car, the front bar, which is an aerodynamic device in itself, has needed complete redesign. You know, what's this front leading edge doing? What's the aerodynamic surface underneath doing? It's way smaller. What are all the shapes and the ducts doing? All modified on both cars to take away the ability for the car to suck itself down onto the road and give grip to the front tyres. Then there's the rear bar, it's aerodynamic, and the skirts, and all these things have got to be designed to appease the manufacturers and how they want the car to look, but they've got to do it in a way that reduces the downforce that we've had and is equal across both cars. Gives me a headache just thinking about it. Oh, I've got a headache. And all of that has happened working alongside D2H, a world leader in CFD, computational fluid dynamics. Modelling of race cars to test theory, componentry, amongst modelled situational and environmental change, which is then further validated in the real world here at the aerodrome. Very much how F1 do it. So all this week, neutral drivers will endlessly run up and down this aerodrome, collating really detailed data at a range of controlled speeds, at controlled acceleration, because when the car squats, its aerodynamics change, under controlled braking, because when the car brakes, and pitches forward, it's aerodynamics change. And they'll do that across a broad range of ride height settings, because that changes everything. Rake, wing settings, the list goes on. And then that information is merged and further validated with the CFD modelling. And that allows the D2H team to use that data with 600 million individual air particles, each with their own formula, to create airflow across and over the car. And importantly, in what we call yaw or cornering, so the air can attack and look at the car from different angles. And again, that needs to be modelled at different air speeds, different rakes, different wing settings, the whole lot. Parts are then made, adjustments formulated, and after nearly 2 years, here we are, making the very final adjustments. And that might be an ever so subtle change to, say, the width of a rear wing, to take away a fraction of downforce. And up at the front of the car, it might be an ever so subtle change to the length of that front lip, just to take away a fraction of front downforce. So as you can imagine, this is highly technical, it's expensive, it's resource hungry, but most of all, it's transparent and it's legitimate. How do I know that? Look behind you. This is the GM homologation team, guys, and up the other end there are the Ford homologation team, Dick Johnson Racing. And they're all under the same tent together, and overseeing all of that there's a whole bunch of supercars technical guys. Now, I don't want to let the cat out of the bag early. I reckon we're about a day away from final results. But I can tell you, the vibe is very good. Stand by. So I'm here today at Wellcamp Airport at Toowoomba, where the Supercars Motorsport operations team are going through one more week, one final week of detailed aerodynamic testing and adjustment. And they're here to nail the final details of what we call aerodynamic parity. There's a lot of people here doing that, and it's all about the debut of these next gen, the Gen 3 Camaro and Mustang, ready for the much anticipated debut at Round 1 Newcastle next year. So before we look at all that, let's just talk for a moment about aerodynamics on race cars more generally. Well, it's about fixtures, shapes, designs, wing elements to push the car's tyres into the road to give the car more grip, which fundamentally means a driver can drive the thing round a corner faster and brake a whole lot harder. The wings on a race car are essentially upside down aeroplane wings. And there's a big trade-off to all of that. It's called drag. The more aerodynamic downforce you put on a car, typically the more drag you create, which is just like a big parachute, and it kills straight line speed. So aerodynamics, or wings, really made their way into motorsport. 1968, Monaco Grand Prix, Graham Hill. He smoked them when they put a wing on that little Lotus 49. 2 weeks later, Chris Amon's Ferrari. They put wings on it. He was 5 seconds faster than his teammate without wings. 3 events later, the whole field had wings on their cars. That tells you everything you need to know. Now, in our touring car world, wings, aerodynamics really started to appear in the early 90s. Now, Bathurst, about 300 k's, we probably have somewhere around 800 kilos. That's nearly a little car sitting on the roof of downforce in our cars. And a Formula One car, it literally makes a couple of tonnes. It could drive upside down on the ceiling easily. But in many ways, we are our own worst enemy, because motorsport is excellence in engineering. So we found ways to continually increase the downforce with minimal drag. But we need to go the other way. We need to make the cars not grip the road, harder to drive, slide around more, longer braking distance to tease out more overtaking. That is the spectacle we're trying to create. So essentially there's 4 really important things happening right now behind me as part of this overall process. Number 1 is reducing the downforce on the cars from the cars we have now by around 60%. But we're going to do that while maintaining a nice balance front to rear. Number two, we're doing that in a way that will allow the cars to race closer on the track without upsetting each other as much aerodynamically. Number three, we're making sure those aero downforce and drag figures are exactly the same across both cars, across a range of speeds, a range of car setups, and a range of aero permutations. And number four, maybe the greatest challenge of all, working alongside Ford and General Motors, is ensuring that the wind-licked surfaces of the cars and its design features stay largely very true to the road car that it represents. So 18 months of testing, aero testing, manufacture, more design, more testing, CFD, making wings and end plates wider, narrower, different shapes, making under trays and front bars longer, shorter, different reactions with the ground, making shapes on the cars, steer air this away and that away. And amongst that process, right from the start, has been high-level, detailed CFD modelling, computational fluid dynamics, by one of the best in the business from the UK, who are out here right now, again, helping validate the work that's being done. Well, the team has just about nailed it. Total downforce, as of about 45 minutes ago, they're down to 1 kilo difference between the cars. A little bit of detail work, a few 1%ers to do on balance and some different speeds, but they're pretty well there. That's brilliant work. So you know what I say? Roll on Newcastle. Yep, absolutely roll on Newcastle. And I've got to say, hand on heart, I love these motorsport operations. Guys, some of them used to work for me. They have worked extraordinarily hard for the last couple of years to achieve what I just said. And they don't lie to me. I was there, they're the numbers. And to give you an idea in that aero test, I said down to 1 kilo. The last two changes that they did on both these cars, and as you can see, they're completely different shapes, but they got them right. The microns they went down to. See, there's just this tiny fillet here, this tiny little piece of bodywork that you'd think does absolutely nothing. That was reduced by 6 millimetres. Can you believe that? What's that, like maybe 200 mil long? Was reduced by 6 millimetres just to take a fraction of drag, parachute, off the front of the Camaro to equal the Mustang. On the Mustang, if we come around to the back, I'll just sneak through here. The very last change they did on the Mustang was at the back of the car. This gurney on the back of the boot here, they reduced the height of that by 6 millimetres to get the drag at the rear of the car and the downforce the same as the Camaro. I mean, that's how exacting this has all been. And there's little things you notice, like, for example, we don't have a gurney on the back of the wing anymore. We used to have well, I can show you in the cars today. We have a gurney that sits up here, I think it's about ½ an inch high, right? So that creates disturbance at the back of the car. So when the car here behind is following, that makes the front of this car not work so well. So by getting rid of some of those devices, cleaning up that, they'll make them race closer. And then finally, the engine story is a good story. We covered that earlier in the year. But here's the engines, two completely different architecture engines, right? Completely and utterly different, but they've nailed those as well. 600 horsepower, 600 horsepower. So they're 50 horsepower down from where we are now, but because they've taken all that drag and downforce off the cars that we spoke about, 60%, means the engines, these cars are doing the same top speeds, confirmed yesterday, as the cars we've got now with less power. Now they've got a little more torque, which is going to make them harder to drive off the corner. That's your sort of low down grunt. So, I mean, it's really exciting, but the really good news for me is turn 8 here at Adelaide, when they're flying through there yesterday, they can't go through there as fast on these cars because they don't have the downforce. So the drivers have got to work. So seriously, well done to the team. This is an enormous task, and now all the teams have got a lot of hard work over Christmas, the next few months, to roll these things out at Newcastle. And a little bit later in the day, I've asked our graphics guys, just grab me some liveries off our cars today and let's drape them over a couple of these cars, because I want to show them to you before we leave here today. Well done, team. Great.